developer advocate for Truffle and Consensus key AVM, but that's more like a secret, but I guess that's alpha about my personal life. But today we're here to only really talk about Truffle. So how many of you guys are smart contract devs here? Cool. How many of you guys are always like, what the F is happening sometimes, you know, when things go wrong? Yes? Okay, maybe not everyone, but maybe just me. So that's kind of my agenda for today. So how the F are we going to figure out what's happening? I have like a whole list of things to go over. So you could call this the most ambitious live demo session that I can do for 30 minutes straight. And hopefully everything will work. If it didn't work, that was planned. Yeah, let's begin. So I'm going to start off with kind of the base of what the transaction tooling for Truffle is based on, specifically decoding. So if you guys are familiar with existing decoders now, so that's going to be something like ethers, for example, what they do is translate this hex data. So I guess another question for the audience, how many of you guys can tell me what that hex data means? Nobody, right? Okay, so that's what a decoder does, right? But existing decoders fall short. They don't often give us things like call data, storage variables. We want extra information like type. Decoders often don't, get source code, right? So we'll often get ABIs back, but not hey, wait, we can call Etherscan. People have verified this. And the last piece is if something breaks, don't just break on me. Just tell me what has broken, but if something does pass, give me that information. So how do we fix this problem with Truffle Decoder? So this is Truffle's I guess it's more relevant if you're a front-end developer maybe, but it's an open source library that essentially allows you to decode transaction hashes. So what does that mean is that we take this hex data and turn it into transaction insights. So if you've seen this tab in MetaMask, that's actually powered by Truffle. So I'm going to start my series of live demos. What does that look like if you want to use your decoder in your project? We'll get into smart contracts later, but this is kind of the basis of it all. So let's talk about the decoder, right? So what this looks like is pretty straightforward. The first thing is going to be you can decode it into raw data. So that's going to be a TS node, 1A, blah, blah, blah. And the process is very simple. It's just, this is going to fail. The first thing you need to do is set up an environment. So in this case, we're going to be decoding transactions that are on mainnet. I'm going to actually fork mainnet locally using Ganache forking. Damn it, this is already in service. Okay, let's try this one for 9545. Nice. Okay, cool. So I'm going to go to my environment, change this guy. And so essentially what this allows us to do is interact with a fake version of mainnet locally. So I'm going to do this again, and this is just something random picked from Etherscan. But as you can see, we get the environment, we get the transaction info. This is actually using Truffle's fetch and compile to get that contract source information. And eventually it all feeds into the decoder to create something like this. So this is the raw data form of something that you can see is very long. But the function, I guess, was called registry with fallback, and it has all these arguments and the types. A lot of this is hard to read, so there is also a human readable form called TS node 1B. And as this runs, look, you can understand this way better. Woohoo, this is human readable. That's kind of the example of the most simple use case. Other ways that this decoder is pretty powerful is it does pattern recognition. So if you guys are familiar with the multi-call pattern when making transactions, so think a multi-call and then it will call little calls underneath, the decoder will actually go through and step through all of them and whatever. So this guy right here does the multi-call because it has to pull so much information. I'm not going to do it live, but as you can see, this version is a multi-call, and then it goes down and it decodes each voting call that comes from it. So that's the multi-call decoder. And then the last piece is storage. So decoding storage variables is a little bit different. The change here is going to be you have to know what the mappings are beforehand. So that's kind of the only, you can't auto-detect that, unfortunately, but you can actually decode storage variables. For those of you who don't know, you can't do that with the other decoders, so I'm sorry it's not as cool as I could say it is, but I'll just prove to you that it works. And that will be the first section of my live demo for decoding. And then after this, we'll actually get into the smart contract stuff, which is probably more exciting. But anyways, that's what that looks like. Let's move on right here. Okay, so we've demoed some shit, but now, like, why do you guys actually care about this? Let's get into things that actually make your transactions transparent. So the first thing is we've taken this decoder and plugged it into Truffle Dashboard. So how many of you guys are familiar with Truffle Dashboard? Okay, nobody. So let's take a step back. How many of you guys heard that girly ETH, like, people are paying for it now? Okay, how many of you think that's like dumb, right? And how many of you guys are like, that's really scary if I lose now this test ETH? I think before we were really private about our private keys because we don't want to lose our mainnet ETH. So we have like a separate development environment, a wallet just for girly ETH. But now that's kind of worth money too. So how do you fix this problem is through Truffle Dashboard. So Truffle Dashboard is essentially this view that allows you to deploy transactions and make transactions in your smart contract process by signing with your MetaMask wallet. So you'll never have to expose your private key in any case. So in this case, I'm going to show you what this looks like. Oh, this was in running node. Okay, so basically, if I just run a Truffle Dashboard, it'll bring up this wallet, or this view, and then I can choose any one of these, I guess, networks. I'm going to be using Girly. And so the thing that you can do then is just do a Truffle migrate network dashboard. And here I will be migrating things through, what do you call it? MetaMask wallet. So I'm not going to spend this ETH in front of you guys because I don't want to do that. But I can show you something really cool. So if I was doing something, for example, like running a script, I could also do this through the dashboard. Oh, whoops. Nah. Cool. And so this is actually where we've plugged our decoder into the dashboard. So you can imagine as you're doing your development lifecycle, you can see what's happening as you deploy. And it will decode all of that information into telling you like what variables are being passed in, et cetera, like that. So this is Truffle Dashboard. This is just hosted on localhost. So if you're using like a hard hat project, you should be able to connect to localhost as well. I don't think this works with Foundry yet. Anyways, I'm gonna hit confirm. That is deployed to Girly. This also works with like the, okay, this is slow. We're just gonna move on because Girly is slow. But yeah, what's next? Yeah, okay, so that was the decoder plugged into our dashboard. So with the decoder as well, you can actually do stuff like debugging your contracts with a local debugger. So one thing that we often run into is like, oh, freak, I'm losing money, something's going wrong. Once you deploy a contract, you're kind of shit out of luck. Like, how do you figure out what's going wrong? How do you actually get some more insight into what the problem is happening? Well, we do something with the Truffle debugger. So what the Truffle debugger actually allows you to do is pool transactions either locally during your testing process or from like mainnet, Girly, whatever, if you fork that locally, and then you can replay that transaction through your UI or through the CLI. I will actually demo what that looks like. So how the debugger works is going to be a few different things. So there's the ability to do it inside of a test. So in this case, in this minting test, if I want to interrupt this testing, I can just do a Truffle test debug. And it's loading. So that was the first test. It'll interrupt it. And essentially in this CLI view, you can just like go through. You can set breakpoints and like go and then see what your variables are and allow you to basically step through transactions that happen, right? So this is interrupting a test. You can also do this with actual transaction plays. So I'm going to show you one thing. There's this combination of debugging with fetching the external source contract to grab information that you might not even have on your own local computer. So I'm going to start off by doing one thing. I'm going to verify those contracts I just deployed, the rentable NFT. Run verify runnable NFT network dashboard. Hopefully this will work. So I'm going to verify this on Etherscan. What this happens now is I'm going to grab this transaction ID right here, and I'm going to go to a completely different project. So I'm in this project. I have none of that code. Like, I want to actually replay this transaction, right? So I can go, and if I do, that was a girly transaction, so I can actually do it through here, create a network, fork, girly, and then the latest block. Let's do 9545. Nope, that's already in use. We'll call that development. And then start Ganache. Okay, so what I've done so far is I've forked a local version of girly. That transaction that I just made, that minting, should be on girly. So if I do a debug transaction, hit development, and then this is the transaction hash, it should, and this will take some time, what it's doing right now is fetching that contract, verified contract information locally, so that we can step through it. And hopefully, after some time, this will work. Yeah. So you can imagine if you had done this like with any other contract, that's how it would get pulled in. It will take some time depending on the complexity of the project. But anyways, same idea. You can go here, set token URI. I'm like, oh, it was my token ID that was broken. I was expecting to be 2, but it was 1 or something like that. And then you can like step into it, step out, and do the whole shebang. So this is powered by the Truffle decoder as well. So again, leveraging that library to allow us to figure out what the fuck is going on. Kind of to backtrack, this visual debugger right now is only available if you are starting with a Truffle project. The test interruption that I showed you is only available if you are starting with a Truffle project. If you want, you can also just do all of this through like a Truffle debug, paste the transaction hash, and then hit your network. That will be usable with a hard hat project. But it's like experimental phase. We're still working with them, so feel free to be a beta tester if you would like. But I think that's all I have for debugging. Hopefully that was super cool. I'm gonna move on. What's next? Yes, okay. So something that I've noticed actually working with developers in the space is the debugger is super cool. It is kind of overpowered. So like, how many of you guys, when you were a developer starting out, what's the first thing you do when you try to figure out something's wrong? You just log it, right? It's just like a heck ton of like console logs. If you started out with Truffle, something that we weren't able to do is we focused building the debugger first before we built the console logs function. So it was a little bit of like a chicken before the egg kind of thing. I don't know if that's the correct analogy. Just think of it as a motorcycle bike for a tricycle rider, right? Like, hey, I just wrote my first smart contract. Let me use the debugger. Like, no, you actually need to log shit. So actually, this is kind of like a big announcement. Truffle does support logging now. So if you are using a Ganache local test instance that I showed you, so local forking, unlocking accounts, that will support Ganache's console log, Hard Hat's console log, and Viper log. So if you are in a different project, so not using Truffle, Hard Hat, or Foundry, you will still get their console information should you decide to pair it with Ganache. However, if you are using Truffle, there's an ability to make it really pretty. So I'm going to show you what that looks like. So if we dive in, basically, in your Truffle config, you can, I didn't add it here. Oh, here. You can basically say, okay, I want it to be really easy to find wherever I log stuff, right? So you can do anything here, like make it, I don't know, more professional, but that's not me. That's whatever. The second piece is prevent console log migration. So like when we care about gas fees and employment and stuff, console log, like deploying your console statements is gonna take up gas every time you execute that transaction. So this is also a protective mechanism to put in place. Say if you wanna deploy to mainnet, this will just automatically instruct Truffle, hey, no, don't include all the console stuff. Anyways, what does this actually look like? So you might be used to the typical flow of like you have to dive into your kind of like local test chain provider and you'll find it embedded in like that log of all the stuff. Truffle test does make it a little prettier. So basically I would just go here. I'm gonna hit an import truffle / console.sol. And I'm gonna do that same thing. I'll just do it here. Console.log. This is my URI. Cool. And in the same way, if I run a truffle test, now, dang it, what is happening? Project expected. Where did this come from? Ah, here we go. Coolio boolio. So if I get this running now, look, the logs are so much easier to access. This is really pretty. One-man audience, that's okay. But anyway, so moving forward, that is the, what do you call it? That's the console log. And the next piece is, like I was talking about, Ganache, right? So Ganache has zero config forking because we utilize Infura's free archive node access. This is really cool because you can also use it programmatically, like in JavaScript. So how many of you guys are familiar with MetaMask snaps? Nobody. Okay, cool. So MetaMask snaps is essentially the ability to extend the functionality of MetaMask. So think anytime I'm sending like a wallet transaction, I can interrupt it and do stuff with it. So something people think a lot is like, hey, when I sign this, I want to know like what's going on if I hit confirm, right? So basically, one of our snaps engineers, Frederick, near and dear to my heart, made a MetaMask transaction simulation snap, where essentially it interrupts the status, finds that basically the instructions, and as you can see here, he creates a Ganache instance, forking mainnet, and then simulates that transaction on it so that when you actually are in your MetaMask wallet, you can see what the simulation result is. And if you don't like it, just hit reject, and you are great. So anyways, that's kind of also the power of Ganache. Oh wow, I have so much time. I talk so fast. Okay, so let's just talk about future stuff because I guess we're already done. Yeah, so what's next? Like I said, if you guys thought that visual debugger was really cool, we are working on support for that for Hardhat. Again, if you want to use it right now, it's only in its CLI format. The other piece is Truffle is actually really focusing on layer 2 tooling and roll-up tooling. So if you heard, I represent both Truffle and Consensus ZK EVM. That's because there's a hell of a lot of synergy there. If you want to talk about L2 tooling, I can spend the rest of the 12 minutes doing that. But you can think of stuff like creating development environments, right? So especially when you are deploying to a lot of different chains, each of them will have different setups. You might want to group them by test, dev, prod, for example. That's going to be like a like something that you can do with your configuration. Another way to put it is probably like declarative deployments, if that makes sense. Essentially, an instruction manual that says, hey, I don't want to figure out all the logic of scripting throughout all these different chains. Truffle will just do it for you. That's the future of layer 2 tooling. The next piece here is going to be detached Ganache. So again, I think this is focusing more on the layer 2 space. I guess this makes sense because we're at interop. But you can essentially think, let's do a like fork, and then, oh, I've used up all my ports. 1545. So imagine you want to create like a multi-test chain environment, and then I could create another one with like a, pretend this is optimism. I'm just gonna do this like that. Whoops. Detach. And so basically, both of these are running in the background. And if you do an instances list like this, you can actually have a bunch of Ganache instances in the background, and you can imagine in like kind of a multi-chain world, you could have multiple local environments running and then having them interact with each other. Otherwise, the current process of doing it is actually just deploying to their actual like Optimism Gurley, Arbitrum Gurley, or like the live test networks, which is like really a painful experience. So anyways, this is kind of like a bonus item that I had. But then other than that, in general, if you've noticed, we're really just focused on visual workflows. So that's kind of where Truffle is headed. And if you want to learn more or find out like when things are happening, when things are being released, we do community calls once a month. Just follow us on YouTube, and that's where you'll find us. Thanks.